We had a very successful first 4 hours of class with the students at the Technical University of Eindhoven, and put forth the idea that the management of process, the management of configurations, be it a mechanical configuration, electrical configuration, a hybrid of the two, or a service configuration, was basically all the same tied together processes, and it ties back to the work that's being done by the G33 committee out of the SAE International Organization. The G33 committee is responsible for configuration management, and they've just finished authoring Rev C to EIA 649, which sets forth the basic principles of configuration management and then gives examples of how those principles are implemented. So configuration management, from my perspective, is something that is ingrained in the human experience, going from the earliest need to be able to reproduce something with the processes or recipe, if you will, controlled by the guilds, to disassociation of the guilds, or dissolution or disbandment of the guilds into the industrial era, and then coming round full circle to specialty manufacturers of products like GoPro and some of the others, where they carve out a market niche that never existed before, and the technology is again closely held as it was in the guild days.
And I never saw configuration management as a mechanism to the innovation. I do now. But I always saw configuration management as a mechanism to controlling the development process in general. As in, without this tool, these sets of techniques, and these processes, it's really free-for-all for any kind of product development. From starting, assuming you already knew the platform that you wanted to begin from. The iterations that come from the design, actually building up to the product that we would eventually launch, are things that are controlled or understood or delineated or defined, captured, however you want to call that, in a way through the configuration management. So I know what set of requirements apply to what set of product, or what incarnation or instantiation of the product upon which I'm working at any given time. It's like the roadmap for my product development. I might have a marketing product roadmap, which gives me the general idea of what's going to happen, but my CM is the thing that ties together what is the next thing in this product that I'm building, and that's hardware and software. Whether it's leveraged from existing manufacturing parts, or whether I'm producing this brand new for the first time, those control mechanisms need to be in place. And any changes to what the design intent is need to be understood and captured in a way so that the design folks know what they're supposed to be building, and they're building according to that.
It kind of goes back to the major tenets of configuration management as the international community has defined them in the EIA 649C. The first phase is configuration planning and implementation, which basically says that this is the roadmap of how all the organizations are going to play together. After that, you have configuration identification, which includes things like what are the date-time formats we agree to, what metadata do we agree to capture within the system, which units of measure we're going to use versus how they're going to be employed, because many times we have international collaboration, and if one unit of measure is done in English units with the foot-pound system, and
gallons,
the other measure is done in liters and Newton meters, then you have totally different results, and pieces don't work together. We've seen some major failures in the aerospace industry because of that. The next phase then is to go into the change control, which says that we're going to manage change in a way so that we have it totally vetted between all of the stakeholders involved and not just a limited design community. but also the people that are impacted downstream from the design. And test and verification, or verification audit, if you will, where we verify that the design meets all of the requirements and validate that we have built it to descriptions we have in our drawings, processes, and procedures, and that sort of thing. And then we end up going through the status and accounting, which says that we know where that design is at all phases through the manufacturing. One of the things John was alluding to is the development of a product, and if you look at it from that perspective, very few times do the engineers actually know how to design what they've been tasked to do based upon a set of requirements, and there may be several starts in coming up with a design that actually meets those requirements. Some of them may be met, but then the interfacing elements after you allocate the functional requirements out to the various sub-assemblies and groups to work on, when they come together, don't exactly mesh the way they're supposed to, and this bifurcation of requirements to hardware, software, firmware process then has to be merged back together, so the branches all have to support one another and still be attached to the trunk, which is the base requirement stream.
For me, the two big ones are exactly the understanding the requirements and holding them in place. And when the change happens, it's understood and articulated to all the combatants, as I like to call the product development folks. In my experience, that's one of the principal areas where cost overruns occur, and we have a system. Our part of the system is designed here. Some other people are doing some other part of the design work. We make some assumptions about what the requirements mean. We start off on the work, we design accordingly, and then we go to put the parts back together again, and it's supposed to perform as a system, but they don't fit together, they don't work together. There's no way this is a contiguous system, it's disparate parts.
I think that some of the modern CAD capabilities that we have now are helping with that. We now have the ability to make a digital twin of the mechanical interfaces. Transmission will have one twin, a motor will have another. We'll be able to look for inconsistencies in fit, form, and function that way before they ever spend the money to actually modify a piece of material, either through subtractive manufacturing, where you take the metal, remove what you don't need, or additive manufacturing, where you only add what you do need. And so it saves some of the problems that we've seen in the past, where the design looks really good on paper. When they build everything up and try to put those sub-assemblies together, something was forgotten. It also helps you define what types of interfaces aren't being considered, so you avoid problems where you have a component that is supposed to be wired to another component. Both of the subsystems think the other one's doing the wiring harness, and then you come to final assembly and find out there isn't one. And with the digital twins, you're able to model not only how things fit together, but the various piece elements. And then you have the digital thread that connects from the receipt of the raw materials or finished goods from a vendor in the supply chain, and how those all fit together in the eventual assembly sequence. So you have a unified BOM, or bill of material, which says not only these are the requirements for the design of this component, this sub-assembly, this mechanism, but you have the entire flow that you can pull out of there from the metadata, saying these are when those components that have to be on order, this is what they cost, and that's tied into the ordering system, so you have the requirements identified not only for the item you're producing, but the form that item finally takes. Do you end up having a red car, a blue car, green car? What type of fabric do you have on the interior? Those things are ordered in the form of secondary requirements based on top of the basic form, fit, and function of the vehicle itself.
Those common, the ability to bring common graphics or models of the parts together, that's a big help right there. You don't necessarily have to produce the prototype part to find, if you're connected in a good way like that, you're able to take the virtual parts and try to put them together and see where things do not work, rather than build them. As those tools are certainly a big help, but those tools must be easily interfaceable between the various suppliers, as in one can't use AutoCAD, another use some other set of tools, and then we have to try and figure out how to mesh them. There's some way to connect these tools together.
Generally, that's done with STEP and AGIS files, and that's really something that's come along just recently, because the parasolids and the STEP files are now common across all the CAD platforms, which is really fortunate that there's some sort of merging of technologies there and cross-sharing of those platforms.
I've seen when those things, they have tools, combatants in the product development process have the tools, but they don't interface well with each other. And so the end result is you find when you build the first prototype that the parts don't go together. That's a good thing what Kim's talking about here. Then another thing that's very interesting is the audit and testing how to work, because part of the work, if you're doing development work for somebody else, the contract closure activities are contingent. The contract is usually contingent upon some set of expectation from, or has attached some set of expectations legally binding, right, with the players in this development process. So if at the end of the day, I have to have some way of measuring what has been done against what the contract says, and this configuration management audit and verification activities provide me that some confirmation of that checklist as to whether I've actually achieved the objectives of this particular part of the work, this project, or this product development exercise. So for me, CM is very connected to the legal aspects and the contract closing of the project.
And contracts could be an external person contracting or entity contracting with you to produce a certain product, or it could be an internal contract with the management structures that you're reconfiguring a building in order to have your production line be more efficient and eliminate the waste by putting place systems that will bring your just-in-time deliveries and sub-assemblies from vendors into the production line where they're needed, instead of having to pay the extra monies for warehouse space to be able to do that. Another thing that was really interesting that I saw today is Tuesday here in Eindhoven, which is Market Day. And the wonderful variety of fresh vegetables that are being grown here and honed also rely upon the configuration management of their produce and the production facilities and the chemical analysis of the soil which they're grown in. If you're not aware of it, the Netherlands soil is gradually becoming more salty because the water levels are raising due to the warming of the environment, and that stresses the plants. So they've started a development project to be able to find plants that will provide superior produce while also being able to survive in the saltier environment. And the configuration control of the breeding of those plants is strictly monitored. Change control is strictly enforced in order to assure that they can have repeatability of the most promising seeds to produce produce that will survive and allow the Netherlands to be the breadbasket of Europe, as it has been for many decades now.
It applies everywhere.
It does, from the simplest process that you might have, which could be a recipe, to the most complicated process you would have for building up integrated circuit interfaces. And it's been around for a long time. If you can think of a recipe as a process which defines the materials and the sequence those materials are being used, and a recipe that is under configuration management is something that was documented in a form that it remains the same, then these processes go back to the Fertile Crescent, and the recipes that we have from that time were incised in clay tablets, and some of them have been recently translated. One of them is a description of how to do calculus several hundred years before Newton and the rest of the folks started working on it in Europe.
Well, that's true. Even manufacturing, the processes for doing the manufacturing work on your line, those things should be under some kind of control and understanding, and not an ad hoc sort of thing. Even when you talk about tools and techniques like TQM, for total quality management, you don't just start making changes. You understand what it is, you explore what it is you'd like to make better, take some measurements to see how you might make that better, come up with a theory of ways you could make that better, then run some kind of test to see if you can make that better, then learn from that test, and if you can, update your procedures accordingly. Okay, so this worked, so I'm going to change my procedures, my work instructions, how my process rolls out, because I've done this exploration, I understand the variables that I need to understand, and I make the requisite adjustment to the line. So it's all a kind of deliberate and formalized approach to how the product or how the capabilities of a particular manufacturing line are extended over time.
That's true, and if you look at the base descriptions in the International Organization for Standards ISO documents, as well as IEEE and this CMMI and CM2, ASME Y14 series for drawing markings, all of these things are documented processes under rigid change management, and they all have the configuration management tenet as how those are gone about and how the changes are implemented, rolled out. Analysis is done via whatever measurement system creates your metrics for you, and statistical analysis in order to get to your Six Sigma process point.
Yeah, nobody would entertain haphazardly producing a Coke product, for example, by throwing the constituent parts together randomly. And nobody would randomly decide to just make up a new recipe without some kind of controls and diligence in that approach. It would be like just throwing paint against the wall and calling it Picasso.
No, but you could call it a Jackson Pollock.
You could call it a Jackson Pollock. Yes, it's not necessarily bad, it's just different. That's right.